about it. Okay, let us get ourselves going. Let's talk about what we are going to be doing today. We are going to be covering 3 big topics to hopefully get you ready for the big wind down to the end of the quarter. We're going to be talking about assignment 5 and what we have in mind for you there. And Lottie and Raj sent some stuff out yesterday, but I want to kind of walk it through a little bit with you so we all have a kind of a similar expectation and we can kind of approach it so that it doesn't become a big old killer thing, because I don't think it has to be. We're going to be continuing the discussion about clash detection, really how once we have a bunch of different models, we bring them together, figure out which things are overlapping or clashing, and then ultimately figure out how we fix those things. Okay, and use the software tools to help us with those. And we're also going to be talking about 4D simulation a little bit, which is this whole notion that if we have a bunch of elements in building models and we want to simulate the construction process over time, we could assign elements to tasks in a timeline and actually come up with a pretty nice simulation of how it's all going to come together. So we'll show you how to do that. Okay, so starting off with assignment 5, let's kind of talk about what you're going to be doing there. And at the high level, here's what's going to happen. You're going to continue with the design development of one of the buildings, okay, that some folks have been working on. Okay. The idea here is we're going to start with the preliminary design that has been proposed by some member of a team, okay? And we're going to get to thinking about who's going to be in your team in just a second here. Okay, and with that preliminary design that you've been working on for assignment 4, okay, we want you to go complete the structural system. So in assignment 4, we had you at least put the columns in place. Some people put beams in place. If you already have beams in place, you're one step ahead of the game. Okay, so we want to go ahead and continue with the structure, putting beams and beam systems in place, as well as putting some foundation elements in there. Okay, just kind of complete the structure a little bit. We want to have the structure in place because we're also going to go through and design all about the plumbing system, the HVAC system, and then ultimately try to get those systems coordinated so that as they overlap with each other, as they fight for the same space, you have to sort of work out, just how they're going to all fit together and resolve any conflicts that you find. So it's really all about just kind of coming up with just many of the different systems, which classically give us some problems as we try to coordinate them, and just in a microcosm, go through and experiment with what it takes to actually try to sort that out. Yes?
Are the electrical systems usually laid out in them as well? Or?
Yeah, actually, sadly we didn't get very far with that in terms of doing it in this class. We're going to keep on going with that like in the B class, but yes, what'll happen in the same sense that we've been doing other types of systems, like lighting and switch locations, all those get laid out. The electrical, if the issue of the wiring and whether that's laid out in detail really depends on the precision that's necessary for the building. For example, like in most residential work, you'll just indicate the endpoint locations. The electrician will actually sort of figure out, given a panel and the lighting and the switching, how to go through and run that, because there's a fair amount of flexibility. In a plant or a hospital, it's probably much more precisely laid out where the locations of the conduits get laid out very precisely in the BIM system so that that can stay coordinated with the piping and everything else. So, yeah, answer is yes, but like a lot of these things, even with plumbing systems and stuff like that, residential things which are not so complex, don't have so many endpoints, there's more flexibility, they tend to have endpoints laid out with people filling in the gaps. Higher precision hospitals, oil plants, things like that. We just do it all in greater detail, as the risk goes up. Okay, so we're going to go through and have you design a couple different systems, and you're going to do this in a small team. So let's talk about what that means. Okay, so in terms of a small team to me is somewhere between 2 students and 4 students, something like that. Okay, and let's talk about teams, because teams are actually kind of there's good and bad in teams, as you probably know from your other projects. Teams are great from the standpoint that, hey, you can actually sort of split the work up and hopefully do some things in parallel. Teams are a little bit tough in that there's a coordination hassle in that trying to get everyone on the same page and get your work together gets to be tricky sometimes. We're having you do this in teams because that's really the way this would be done in industry. There really isn't design of a big building like this that gets done by a single person. So even though that may seem easier in some ways, the whole experience of trying to coordinate with several other team members is really a part of the genuine experience. So we want you to have that. As far as the number of students, we'll go ahead and approach it this way. We'll outline a whole amount of work in here. As you approach that, at least 2, okay, but no more than 4, and you can sort of choose what feels appropriate for you. The tasks are really designed so that they really can be completed separately and in parallel, and just however many students you choose to work with to divide the work up, it's that trade-off. You'll have more people to share the work with, but there's more of a coordination hassle in terms of putting it back together. So choose what you want to. In terms of the students and the teams and stuff like that, really the team is going to be responsible for completing all parts of the assignment. So, choose the right number of students, and if you have students on your team, it doesn't have to be all from this section. It could be people in the evening, people just watching remotely, people in the morning. That doesn't matter. If you have students who have different numbers of units they're taking the course for, someone's taking it for 2 units, someone's taking it for 4 units. Go ahead and balance your work out internally amongst yourselves in terms of trying to be equitable about that. Okay, so it's just the team is responsible for completing the package, and then ultimately how you divide that up is up to you guys. Okay, as you choose a project to carry forward, think carefully about which one you want, because it's not important that you choose the most incredibly architecturally brilliant and complex and delightful building to carry forward. You have a limited amount of time to get this all done and get things completed between now and the end of the quarter. So if you choose a very complex and architecturally interesting building as a group, you may be taking on a little more work in terms of designing the structure and how it's all going to fit together. Okay, so don't necessarily go for the nth degree one. You can go n-1 or n-2. It's okay not to go ahead and choose the most complex one. Realize if you do choose the most incredibly complex one, you as a group are taking on a little bit more work. Okay, so I don't know. Think about where you want to go on that dimension. I just want to caution you about that, because you don't necessarily have to go for, this one's more about the coordination than it is about the architectural brilliance of the completed design. Okay, in terms of tasks going forward, architecturally, we want you to go ahead and, let's keep going with the design, place some interior walls in that building around the stairs and the landings, around that kind of core space, we'll put some interior walls there. Also go ahead and articulate some restrooms in there. We want to have some restrooms in there because ultimately I want you to plumb them. But think about creating some restroom spaces for men and women at each level. And as a guideline, if they had 5 toilets or urinals and 5 sinks, in that lavatory, that'd be fine. If you want an example of what a good kind of shared gang sort of toilet for a building is, just go right next door. Like here in the Wong building, there's a really nice example of kind of a big shared restroom with a lot of toilets, a lot of urinals and sinks and stuff like that. Just something like that. We really want you to go through and design something that just has a little bit of complexity to it so that you have something to go through and plumb. So it should have more than just like 1 or 2 units. Go ahead and have a couple in there. Again, you only have to, you're going to define them, and then we're going to go ahead and only plumb one of them. You're only going to plumb the women's room. But go ahead and design those spaces out architecturally. And just as you're doing that, make sure at least one of the stalls has that ADA clearance. Similar we did in the first assignment. Make sure there's room for like a 5-foot diameter circle. Kind of switch around in there. And again, go right next door if you need to kind of get an example of what those look like. Okay. For those, go ahead and omit the fixtures right now. The MEP person is going to go ahead and put the fixtures in. Okay, you kind of design the space. Okay, place interior walls in a small portion of one part of the design. So put some interior walls, not over the entire floor, but some corner, some space of it, where you can really go through and put some interior walls, put a ceiling in there, put some doors in there. You're going to sort of fit out with the tenant improvements some small piece of the building, like 2,000 square feet. Not the whole floor, not all the floors, just some little piece. Because in that little piece where you put the ceiling, you're going to put the ductwork in there too. Okay, so just again, some small piece. We can imagine that you're going to copy and paste it up. Yes?
So since we're doing just interior walls, are we just doing the plumbing and HVAC system on one floor, or are we doing this all together?
Actually, you'll do it on one floor and then you'll ultimately copy and paste it on up. Okay, but really, very good question. You're only going to really design it on one floor, and then at the end it'll be a big copy and paste.
So every floor has a bathroom?
Yes.
But not the interior?
Yes, correct. Yes. So, and the idea with the bathroom, typically those end up being sort of near where the stairways are and the elevators, because even if your building does all sorts of swoopy doopy things, because the stairs run up vertically, almost always your restrooms will be able to run up vertically and you'll get a nice riser. You get what I call a stack. Okay, and they'll tend to be in the center or the core of the building, you know, outside of the range of where the interesting gymnastics are happening. Okay, so a little bit of architectural work. Structural work. The structural work, not too much to do there. Most of you have already done most of that. You put the grids in there, you put the columns in there. Just go ahead and put the beams in the beam systems. We need this, again, to sort of make some guesses about what those are, what the heights of those beams between the different columns will be, fill them in. We need to have some beams in there so that we could actually have an issue with getting the ductwork in there. Okay, so some beams in there. Also, foundations. Oh, that's actually a very easy thing in terms of doing isolated footings under the columns. It's just a type of element you place under each of the different columns. Yeah, that's actually a pretty easy task. As you do this task, though, you know, go through and think about the depth, because if you put really tall beams in, it'll make it harder for the ductwork to fit in. Okay, don't put incredibly squishy beams in there, because that wouldn't be very realistic. But ultimately, we'll get some help in sizing this. Okay, you'll probably do the architectural and the structural design in the same model, the same Revit project, just because you've already put the columns in the same as the architectural. Realistically, I'd probably separate those into two different models, but for this assignment, it's okay to keep them together. On the plumbing systems, go through and create a separate Revit project and link it to the architectural model. Okay, again, we want to have just sort of two different models. It doesn't have to be two different models, but that's probably more typical of the way it would be done, where you have the architectural model, you create a new mechanical model that has all the fittings in it, and then you link it in and then do all the piping inside the mechanical model, as opposed to doing it in the architectural model. And really, that's going to be more about kind of keeping the work separated. It allows you guys to work independently, so that if someone's completing some architectural work and someone's doing the plumbing work, you don't have to sort of be in complete sync. You kind of work separately as two separate files and bring them back together, which really sort of mirrors the way things work in industry. Yes, Sarah?
How does it work if the two files are on two different computers?
It's really just at some point, we just need to share them through Dropbox or emailing them to each other. You just need access to a copy of the file. You'll link to the architectural file. If the architectural file gets updated, or the plumbing one, we just need to transfer that file back and forth between you. And when you reopen it with a new version in place, it'll show the changes reflected in.
Is there a way to link it through the cloud rather than?
There is. There's a whole other way of doing kind of model coordination called BIM 360 Glue, okay, which does it. In terms of the coordination, we've been looking at something called Navisworks, which is more of a desktop-based thing. There's also cloud-based coordination through this Glue product. Either one will work in terms of what's going on. We'll experiment more with that next quarter, okay, in terms of doing the cloud-based coordination, which is, I think, really a better way to do it. In the short run, though, just pass files. That'll get us through this one. But no, you're right to think ahead, because there is a better way. As opposed to passing files around is really, in the scheme of it, it's kind of dead. In the scheme of things, it's really much more dynamic, much more real-time to actually just put things in the cloud and everyone be accessing the latest version on the cloud. So if you want to interim like that, I use Dropbox. Do you guys use Box, or what do you guys use for sharing files? Okay, great. So if you have a shared Dropbox folder between your different folks on your team, you can just point to that. Dropbox is a really good, simple solution. I like Dropbox. No endorsement, but it's a good solution. Okay, for the MEP system, put in some plumbing fixtures. Again, you're going to do this on sort of one level. Put in those hot water supply lines, the cold water supply lines, the sanitary lines, much like we did here in class. Just kind of route up. In this case, I'm going to ask you to just route the women's room. Okay. And then after you do all those things, then copy and paste these elements to the other floors to create an entire stack. So do it at one floor, put a vertical riser in, copy and paste up, and then you'll have to stretch that riser and connect them all in. Again, you'll actually have a whole stack. So hopefully that's not too bad. It's pretty much one restroom copied and pasted. HVAC systems. For someone who likes doing the HVAC design, okay, go ahead and put in the supply terminals and the air terminals. Again, based on some notion of the volume and a number of air changes per hour, kind of place some terminals. go through and route in some supply ducts and some return ducts. Okay, you don't actually need to worry about the air handler. Just sort of kind of run that. It's just kind of going off into space towards the core, and we'll imagine the MEP engineer is going to go through and put an air handler over here right now. We're just going to run them out to the space. Again, for this ductwork, do it specifically in the space where the ceiling is, in that sort of tenant infill space. So you don't need to do the entire building. Just do that portion that you sort of fitted out. Yes? So.
As far as the plumbing goes, in terms of like where you ended, talking about the risers, and where exactly do those like run from and to?
Ah. No worries. What'll typically happen in that sort of little mechanical space where the vertical thing is, it'll all go down to the basement, or up to the roof. Either way, draining on down or the water supply being fed on down. There'll be a big mechanical room, like in some either intermediate level in a very tall building or all the way down on the first floor or maybe up on the roof. So for now, imagine they're just going off to some place that's handling it. Okay, but no, good question. And it's typically, it just varies on the strategy and what part of the world you're in, whether they go up or down. Well, drainage always goes down. Yes?
Would you make specific about how many ducts and air changes we have, like, for depending on the size of our building, or does that not matter?
Just really more, think about it for this space. For this 2,000 square feet by 8 feet tall, and minimum of 4 air changes an hour, you'll need that many air terminals here, run the ducts off. Sort of imagine that, and what will happen in most buildings is, for this wing of the building, it'll all run to an air handler over here. For this wing of the building, it'll run to an air handler over there. So, you're fitting out a small area, and then you can imagine that it would be replicated, for all the different wings to get much bigger, and then copied up to the other floors too. Okay. But what I want you to do on this one is, before we go copying it all up and down to the floors, okay, do some clash detection first to make sure that your structure and your ductwork are kind of working on one level, because you'd really rather sort of work out the fundamental issue of how things are going to pass each other and what the heights need to be. You'd rather work that out on one level first and then copy it up, okay, before you do it for the entire building, because you're probably going to figure out what you need to. In those 2,000 square feet, you'll probably figure out the essential issue of really how things have to pass and what the beam heights are. So do that before we copy it up. Yes?
So, even the idea is that every floor is pretty much identical structurally and architecturally.
Yeah. Well, as a gross simplification for this assignment, okay, and in reality, the whole issue of the restrooms and the core, they're probably pretty similar architecturally. Structurally, as we move up through the building, we'd start typically seeing some sort of optimization where, the columns would be getting smaller. The beams wouldn't necessarily be getting smaller as they go on up, but there typically would be some sort of optimization as you go moving up. But just as a gross simplification for what we're doing here, just assume that most floors are pretty much equivalent. Okay, general questions? Sort of get the idea? After you go through, do your model coordination. That's this whole notion. We're going to talk about that today. You're going to have some structural elements. You're going to have some mechanical elements. Someone on your team is going to get those together and just sort of see, are things conflicting? And if they are conflicting, actually drive the process of trying to get them fixed. And we'll talk about that today. Okay. Then after you figured it out for that one section, then we'll copy and paste it up. Okay, what we like to do, and we'll show you how to do today, is use the Clash Detective tool in Navisworks to run a clash test. Okay, then save out a clash report that shows the initial clashes. Then you go through and fix some of these clashes, and hopefully resolve most of them so you don't have the clashes any further. The final thing to do, and again we'll talk about it today, is doing a construction visualization. Now for this, we only want to really be thinking about simulating a piece of it. And I'm going to recommend that we just simulate that structure that you've created, because you got some you'll have some foundation elements. You'll have columns, beams, some beam systems, even floor slabs in there. Let's just go ahead and build out the structure. We could go ahead and do a simulation of a lot more elements of the building, but just the basic structural stack works pretty well in terms of, as we go through and build the building, we'll put some foundations down at the lower level. Then we'll put some columns coming up from that as a second step. Then we'll go through and put some beams connecting those columns. Then we'll put some joists between the beams. Then we'll go through and put a floor. And then after we have all that, we repeat. Coming up, beams, or columns, major beams, sub-beams, floor. Columns, major beams, sub-beams, floor. Okay, and again, we can do this in a lot more detail, but just the basic rhythm of doing something like that feels good. And for this, a simple schedule, 10 to 20 tasks max. If you really get into doing this, this could be one of these things where a big construction suit could have hundreds of tasks with an incredible amount of detail, but we don't really need to do that for this. It's really more just the experience of kind of getting some sort of 4D simulation going up of, in this case, the structural core. So here's an example of, kind of the level detail I would probably approach it at. Just really gross. Put the basic foundation down, put the level 1 columns, put the beams, the joists, put the level 2 floor deck down. It's kind of very simple. And it'll give you a real, kind of quick simulation of what the basic building of the tower is going to look like. Sort of make sense? We'll illustrate how to do that today. So that is the breadth. Somehow you're going to put all this stuff together and submit it all to coursework, as well as we're going to have you do the 4D simulation, put that out there on A360 as a way of sharing that. But that's all the details of that. But let's back way up to the high level and talk about the assignment at a real high level. So you get the notion of, okay, working in small teams, different tasks. So one's probably going to take on the architectural, someone else may take on the structural. You'll think, this person who does the plumbing system doesn't have to be the same person doing the HVAC system. But somehow all these little pieces have got to be completed separately, come together, and someone's got to clash it, bring it together, and figure out if there's conflicts, and if there are conflicts, and where those will happen. Now, 9 times out of 10, it'll be something about the ductwork and the beams are just trying to occupy the same space. Okay, so at which point we try to find those clashes. If we find some clashes, we say, hey, we got to do something about this. Either we got to shrink the beams or move the ducts so that they're not intersecting with the beams. Okay, and then ultimately just resolve those. Sort of make sense? Okay, we'll leave it at that for now. Go ahead and dive on in. One of the first things you should probably do before you escape for a holiday and stuff like that, is just figure out who you're going to work with. And it's a short-term relationship. This is not like you're not making a lifelong commitment here. You really have to live with this person. Find someone who's really, really compatible that you like working with, who you can through a very stressful week. Because there's going to be a very stressful week, you can work with effectively and get this done. So people who share similar schedules, complementary work styles, it's all that stuff. Go ahead and find something. There's, whatever, but it's, you know who you work well with. So go ahead and find something like that. But try and, again, don't get too many people on board because it actually gets harder in a weird way when you have too many people you're trying to get coordinated with. Was there a question? No, okay. So let's go with that. So have at that, see if you can figure out who you're working with. If people are like, oh, I have no one to work with, and I can't find someone to work with and stuff like that, please, please, please send a message. Actually, we can do it through Piazza or we got to get you guys surfaced so you can actually have people to work with. So if you can't identify someone you want to work with, send a message to the TAs and we'll post something out on Piazza and try and pull people together. Okay, but much better if you find your own people. Because, I don't know, you do a better job of figuring out who you'd like to work with. Okay, let's pause there. If that's feeling good, let's shift over to actually what we're going to do in terms of getting you ready to do that. Okay, feeling good? Good enough. Okay,